All right, so I want to work on section 2.3. I want to work on some of the problems that we ask us to solve an equation for specified variable. All right, so let's say you had something like x is like 3x is equal to 10. How would I solve this problem for x? To find x, we need to divide both sides by 3. Is it division because there is no plus or minus between 3 and x? So that would give you the value of x equal to 1/3. So now, let's say equation that is s is equal to dy, and they ask us to solve it for d. To solve it for d means you want to find d by itself. So it's very similar to this. You know how you divide both sides, divide by 3. Why? Because you want to solve it for x, means you want to have x by itself. So when you have letter, it does have the same process. So if I want to solve it for d, then I divide both sides by y. So then d is s over y. So when we ask you to solve it for d, that's how you do it. In other problems, let's say we ask you to solve these equations. Solve d is equal ABC, and we want to solve it for letter of B. Again, to find B by itself, you divide both sides by AC. See, in that case, B by itself is on one side and D over AC is on the other side. So again, so when we ask you to solve it for letter of B, means B has to be alone by itself at one side. Solve these equations, 5x minus 2y equals 17 for letter y. You know, think of this, think that you don't have other letters, you just have y. Let's think of, let's assume that you have a problem like this, 5 minus 2y equal to 17. How do I solve these equations? What I need to do is first, I need to move 5 to the other side, correct? So it would be minus 2y equal 17 minus 5. And then you divide both sides by negative 2. Why? Because you want to have y by itself. So when you have a letter, the process is very similar. So here, first I need to move 5x to the other side. So you have negative 2y is 17 minus 5x, right? Then to find y by itself, you divide both sides by negative 2. Because you always want to find positive y, not negative. So y is 17 minus 5x over negative 2. Sometimes when you solve the equation, especially when you're using MATLAB, your answer might be slightly different. Like here, if I can also take this negative and bring it up and distribute it into these parentheses and write the answer as 5x minus 17 divided by 2. See, both are the same thing, but it just depends how you have the answers written when you do your homework. So, you know, they all are the correct answers. So let's go and look for more problems here. So now we have the equations. Solve P equal 2W plus 2L for W. So what do I do first? Let's just say, assume that you don't have any letter except W. You have something like this, look. If you have a problem like this, what would you do first? Don't you bring the 2 to the other side first? And write it like this. And then divide both sides by 2 to have 2 by itself, you know? The same process, it's just you have a letter instead of the numbers. So what I do is first I move 2L to this side. And anytime you move a letter or number from one side to the other side, you always switch the sign. So here would be P minus 2L. You could either see it that way or just say, okay, I'll subtract 2L. Same thing. So P minus 2L equal to W, okay? So you could either do it like this or just move positive 2L to the left and sign switch. Now you want to find W, divide both sides by 2. So it would be P minus 2L over 2 is equal to W. Solve for the letter of U. P is equal to 9 pi U. It's like if you have 5 equal 9U, what would you do? Don't you divide both sides by what is sitting next to you? Doesn't matter what's sitting next to you. When you divide it, then U is by itself, right? Same thing. You divide both sides by 9 pi. So you have U by itself equal that. And it doesn't matter whether you put a U on the right or on the left. Yeah, all means the same thing. You also have a problem like here that this equation is given the temperature formula that shows the conversion of Fahrenheit to Celsius. Okay, so let's say this temperature is given. It's 86 degrees Fahrenheit. Now you want to find the C value. C is that, you could drag the fractions, write it like that. Nine goes to 54 is 6. 6 times 5 is 30. All right, so now we move to section 2.4. Section 2.4, we are dealing with number line and inequality. Now, first of all, what's the difference between equality and equation? Look. X plus 3 is equal to 5. Inequality is x plus 3 greater than or equal to 5. This is a symbol that we use for inequality. Okay, so let's say you have a number line. Number line is a straight line, is divided into equal sections. There is an initial point which is 0. Number, as you go to the right, they all increase. As you go to the left, they decrease. Like, let's say 1 and 5. You understand that 1 is less than 5. In algebra, to say 1 is less than 5 for less than, we use this symbol. This is a symbol for less. Or you could just say 5 is greater than 1. That's the symbol that we use. All right, so here there are, this is the equation. Solve the equation means find the number that when you substitute for x, add 3 to it is 5. Obviously, there is just one number like that, right? And what number is that? 2. So there is only one value that when you substitute for x, you get 5. There's only one solution. Here, we are saying find the number that when you substitute for x and add 3 is greater than or equal to 5. So it's not just one number, there are so many numbers, okay? The process of solving inequalities, this first process is very similar. What would you? You just subtract 3. X is greater than or equal to 2. Means all the numbers greater than 2. It could be what? 2, 3, 4, 5, all the way to positive infinity. See, these are all answers. Any of these numbers, when you substitute for x, let's say I take like 4, right? 4 plus 3 is 7. Is 7 greater than 5? Yes. So one of the main difference between inequality and equation is inequality has so many answers. In that case, since we cannot list all the numbers, if you want to show it graphically, we just draw a number line. We find a point which is 2. And we use the bracket and we put the arrow to the right all the way. So that means all the numbers 2 and greater are the answers. We use the bracket when you have equal, okay? So look, let's say you have here x greater than 3. I want to graph that. It doesn't have equality sign, so you just use the parentheses. If it does have equality sign, then we use the bracket. It means 3 also is one of the number. See the difference? Another example, let's say you have x is less than -5. On the number line, you label a point is -5. All the numbers less, it goes from all the way from here to there, here. So you have x less than equal to -5. Then you use a bracket. That's how to show it graphically. I want to solve this inequality. (14x) is less than 13x plus 5. When you want to solve the equations, let's say you have equations. To solve this equation, what do I do first? I move 13x to the left, right? So that would make it what? 14x minus 13x equal to 5. The same thing here. First, you move 13x, so you have 14x minus 13x less than 5. And that would make it 1x, or x less than 5. Now I want to graph it. If you want to show algebraically what you do, you write it like this. You open a bracket, you put x, and like that. That's how, the kind of notation that we use. Just this part, we use it for all of them. How do you graph it? Draw the number line. You don't have to list all the numbers here. Just pick a number, just say this is -5, right? It takes the parentheses. Why? Because it doesn't have equality sign. If there was an equality sign, then you use the bracket here. Look at these problems. I need to collect all the x's on one side. I have 7x and 4x. When you want to collect x's, always try to bring it to the side that has a larger number in front of the x. See, 7x is larger than 4x, right? So I move 4x here and move the number to the other side. So you have 7x minus 4x greater than equal to -5, -25. 3x is greater than -30. Divide both sides by 3. X is greater than equal to -30, right? So if you want to show with the notation, just open a bracket here, put the x, the vertical line here, and put this around it. If you ask it to show graphically, it has an equality sign, right? So it takes a bracket. So you just draw the number line here, label a point -30. Because of equality sign, use the bracket, and goes to the right all the way to positive infinity. solve the following inequality. Negative 6x greater than 30. Now, one of the main difference between inequality and equation is, in inequality, when you divide both sides by negative, you have to switch the sign. You understand? Look, I need to divide both sides by negative 6. Because I want to have x by itself. Let's see what happens if I do not remember to do this. Switch the sign. Now I'm claiming that x has to be negative 5 and greater, okay? I'm saying all the answers are what? Minus 5, minus 4, minus 3, minus 2, 0, 1, 2, let's say 3, all the way, right? Now, when you solve inequality, you could always check. According to this, I claim that all the numbers greater than negative 5 and negative 5 are satisfying these equations. Okay, let's see. 3. I'll put 3 back here. What is negative 6 times 3? Minus 18. Is minus 18 greater than 30? No, minus 18 is a negative number and 30 is positive. See, on the number line, 30 is here and minus 18 is there, look. So something is wrong. What is it? Well, when you divide by negative, you gotta remember to switch the sign. So x is not greater than, x is less than negative 5, okay? So then, when you graph it, you go to the left of negative 5. So you need to remember this. When you divide by negative, you gotta switch the sign. You could always, you could always pause it, and that give you a chance to write it down or go over the problems and see if you have any questions. You want to solve this one? So what I do is first I distribute 5 and 2 into the parentheses. So I have 5x minus 15 less than 6x minus 2. Now, if you bring the 6x to this side, okay, let me show you that first. I'll bring 6x to this side. So it would be 5x minus 6x, and I move negative 15 to the right, correct? So it would be minus 2 plus 15. In that case, I have negative x less than 13. Negative is not acceptable. You should always have positive 1x, not the negative. So this is like is negative 1, okay? Divide or multiply both sides by negative 1. Multiply both sides by negative 1. So you get, put a negative 1 here and negative 1 there, right? So what do you have? You have x and negative 13. What do I need to do? I need to switch the sign. So x is not less anymore. X is greater than minus 13. It doesn't have equality sign, so you see something like that. Now, there is a way to do this problem so you don't have to worry about multiplication or division by negative. Let's look at this part. 5x minus 15 is greater than 6x minus 2, right? I see here that 6x is larger than 5x. You always collect all the x's on the side that has a larger number. 6x is greater than 5x. Let's see, if you have 6 apples here, you have 5 apples. So you need to move 5x to this side and negative to that side. So then you have positive 2, negative 15 is 6x minus 5x. Then in that case, x always is positive, see? You don't have to multiply or divide because you already have positive x. But how do I graph this? Negative 13 is less than x. The way I always say is, okay, let's say there are two people, Mr. A and Mr. B. Mr. A is shorter than Mr. B. That means B is greater than A. If negative 13 is less than x, it means x is greater than minus 13. And when you graph that, then you see that. Okay, so that's the way. If you do it this way, then you don't have to worry about dividing or multiplying by a negative number. All right, so that takes care of section 2.4.